Hi, this is Dr. Hassan Abdullah with the course Introduction to Natural Language Processing. The topic which we are covering is named entity recognition and the subtopic techniques. So this is video lecture number 7B because we already had the 7A lecture which was the basics. So the supplemental material for this course is available at ezmcq.com/goget. This is a learning management system which provides a personalized experience. So the keyword here is personalized. Personalized. So to get to know these features, I would suggest that you look at these 6 videos which explain the working of this learning management system. And this course consists of 15 topics, and we are right now at topic number 7, which is named entity recognition. So now we move on to the learning management system. So we are here at the question number 11 because the first test 10 questions have already been covered in lecture 7A. So this is lecture 7B. So the question is demonstrate the working of dictionary based named entity recognition system for the sentence Apple Incorporated is headquartered in Cupertino, California. So this is the statement and how it is this NER is done for this statement. So basically it consists of the input sentence which we see which is given here, and the pre-processing of that sentence which usually consists of tokenization, and then the dictionary lookup because this is a dictionary based approach where we try to find out, and then there is the entity matching takes place, and based upon the entity the corresponding tag is assigned to it. Okay, and then the output is displayed. So let's look at it. So this is the step 1 is the input sentence. Here's the input sentence. All right, and then so this is the input sentence, and then is the tokenization. So tokenization, this is divided into tokens, so we have these tokens which I am highlighting. Okay, and of course the stop words have not been removed. They could have been removed as part of the pre-processing. And then there's a dictionary lookup. So we try to basically look up into the dictionary matching Apple. Okay, and so we have these organizations, so this matches with this, and we have a name of cities also. So city names, location dictionary. Okay, and then the country names and the country name, and of course it could be state names also. So the matching takes place. So we see that Apple Incorporated got matched with an organization under the organization dictionary, and so we have Apple Incorporated and we have organization dictionary. So we have this city name matches with the location dictionary, and California matches with the again with the state location dictionary. Okay, and then the tagging takes place. So Apple Incorporated gets tagged as an organization, and Cupertino gets tagged as a location, and California also gets tagged with the location. So this is the basically the output, and in the output what happens is that the entire sentence gets tagged. Okay, so this is the organization. All right, so this is the organization, and this is location, and this is again a location. So if you want to know more about it, so these are the references. So that was one approach. Now let's look at the rule based NER system works with an example. So now it is more involved because now we have to have rules. Okay, and defining the rules based upon the cues, so get an idea something about it, and then based upon the rules are made, and these rules are crafted by domain expert or linguistics. So you need domain expert, you need language experts, or their combination, and these experts basically define the rules, create the rules, and they craft the rules. Okay, so this is much more than just writing the rule. Okay, and then the typical steps. What are the typical steps? First of all is the rule creation. All right, and then the tokenization and text pre-processing, which was done briefly previously also, and here we also perform more text processing. Then we apply the rule, and then is the post processing, because as the application of the rule there may be more work required, so that's the post processing, and then is the output generation. All right, so let's look at this example. Let me clear this first. All right, so So we have the rules. Rules, the system starts by creating a set of rules or patterns, okay, and based upon the linguistic and contextual features, okay. And of course, the rules may be based upon syntactic structures, part of speech tags, word sequences, morphological patterns, and so on. And these rules are, of course, are checked by people, okay, and they are then, of course, they are polished also. So afterwards, the second step is tokenization, okay, and necessary pre-processing. What is the pre-processing steps? Which we already covered: this stemming, lemmatization, normalization, and so on. And then the rule is applied. Then the rule is applied against, and where the rule is applied, the rule is applied against the token. So we have this token sequence, and we have token and against the predefined rules. And if there is a match, okay, then that token is named an entity of the corresponding category, of the corresponding type, or of the corresponding class. And then is the post processing. What happens in post processing? Let me clean this first. So what happens in post processing is that additional post processing to refine the results, okay, handle special cases and multi-word entities. For example, New York is a multi-word entity. For example, Washington Memorial is a multi-word entity. For example, Barack Obama is a multi-word entity. So, and then the output is generated. It generates the final output, okay, and associating with each identity the category label, okay. And of course, so this is what we have. This is the example we had. So person's name are typically capitalized, all right, and we have this token as a person entity, and then we have the location entity, okay, and then we have the final output. So we it looks like this. All right, so we see that of course we can keep them or we can remove the stop words. Okay, so how does the machine learning based NER system works? This is more interesting. So we need to first prepare the data, so pre-processing, and then the feature extraction. This is all automated. Then we have a model, and that model is trained using the features, and then the entity is predicted, okay, and then the entity is assigned. Then is the post processing that was done uh, in this case also previously, and then the evaluation, the quality of the results. This is more involved. Okay, so what is there in the in data pre-processing? So we have the sentences and we have the entities which are manually annotated. So this is how you make this learn. So you know that the labels are there, and the data set is split into the training and the validation and the test sets. This is covered in machine learning, this entire course. And then is the feature extraction. So the features are extracted from the raw text, okay. And this of course this is basically this is machine learning. So we have the word tokens, we have the part of speech tags of the words, and we have the capitalization patterns and the contextual features. So the river bank was crowded. So if the river is there, then we know that it was the river bank. If we only have the bank was crowded, then it could be financial or it could be river also. So once we have the features, once we have the data preparation, then we have to have a learning model, and then that learning model is trained. Okay, that could be CRFs, that could be SVMs, that could be neural networks, and of course, and this learning training takes place based upon the labeled data set. What is the labeled data set? This is the manually annotated set. So once the model learns to predict the label for each token, then the prediction takes place. Model learns, and after the training, the model predicts named entities unseen text on which it was not trained. Okay. So what's going to happen into one of the entity labels or making it as outside the entity. Okay, and then when it's done, then the post processing takes place. So what is there in post processing? For example, in post processing, uh, refine the predictions. For instance, overlapping entities or multi-token like New York can be held in using the biotagging, which I'll cover very shortly. And then we evaluate the results using metrics such as precision and recall and accuracy and F1 score and so on. So this is basically a diagram which shows. So this is the documents which were annotated, and they were trained, and this model was trained on them. Okay, and you have this model, and then you have the raw documents unseen, and they get annotated based upon this model, and then you have this automatic annotation and need to quantify the quality of the annotation. Okay. All right. So what is meant by biotagging, which I just mentioned in named entity recognition? So labeling presence and boundaries of named entities. So we are looking at multi word entities. So the bio stands for beginning of the entity, and then you are inside the entity, and then you are outside the entity. So that's bio tag. For example, Barack Obama was born in Hawaii. Let's look at how the bio tagging takes place. So the bio tagging beginning, inside and outside. So beginning indicates a token marks the beginning of the named entity that I've already mentioned. So how it's going to work? Let's look at this example more. It will become clear. So we have the beginning of the person entity. Okay, beginning person. Then we have the inside of the person entity. Okay, so because it is multi-level. Okay, multi-word actually. And then we are outside of the named entity. Then we are outside of the named entity. We are was is outside. Okay, let me change the color here. So was is outside, born is outside, in is outside. Okay, and then we have the beginning of a location entity. So we have, I'll change the color again, right? So we have the beginning of the location entity, and of course, if this could be a multi-word also. For example, Washington DC, that's a multi-word. So this is how the tagging takes place for the. This is how the bio tagging takes place. Okay. So what is the relationship between bio tagging and named entity recognition? So basically, what we do is uh, we entity recognition outputs in, of course, in natural language processing. So let me go here towards the end. So what is the goal? The goal is to identify and classify named entity in a sentence. Okay. So identifying entity boundaries, for example, New York as a location instead of New and York. Okay. So each word according to whether it is part of an entity or its position relative to that entity itself. So this adds more information to take care of such scenarios. All right. Let me clear this first and we move on. So how would biotagging work for the statement Lincoln Memorial, Washington? It could be Washington. Actually, it's Washington D.C. So biotagging takes place. You have this named entity Lincoln Memorial, and the location is Washington, and you have multiple tokens representing a single entity. So we have this is how it looks like. So Lincoln Memorial, Washington are three tokens. There are no stop words, and they represent a single entity. By identifying the beginning and inner of the entity, they can be joined to form a single representation. However, using bar tagging, we say that Lincoln, beginning of the location, Memorial, beginning of the inside the location, and then we have again beginning of the location. Okay, because Lincoln Memorial is, as you can see, it's a building, it's a structure, it's a location, and that location is inside the location of the Washington DC, right? So this is how it works, this is how it looks like. And then the last question is, how can we convert a structured problem into a sequence like biotagging? How can we do that? We need to define the let me go into the details right away. So define the entity types. Okay, So identify the different types of entities, and what are the different types of entities, which are the names, location, dates, or it could be currency or weight and other things also. Then we do the tokenization, divide into individual units or tokens, right? And then you extract the feature, all right? And that extraction include word embeddings, part of speech tagging, syntactic features, and so on. And then the training and the data annotation takes place. So this is quite involved. And then you have to have the sequence labeling models also, right? And then the inference takes place. Predict labels for new sentences of sequences of token. I'm sorry. Predict labels for new sequences of tokens. These new ones are the unseen ones, because now the model is has been trained, and then the evaluation takes place. All right. So that's all I have for this lecture 7b, and thank you for your time.